Hi Year 10, welcome to your revision video for the last term, preparing you for the midterm inshallah. In this video we're going to go through some idea of bearings, circle theorems, the most important circle theorems, area of polygons, angles and parallel lines, and finally the standard units conversion, how you convert these kind of units. And we're going to go through the basics here. This video is, remember guys, is a revision. We covered the whole thing, everything that's been covered here in this video has been covered prior hand in our classroom in details. Okay, bearings. In this question, you're gonna use a protractor. Protractor is basically the one with the numbers here to measure angles. Bring it with you. Also, for the other questions, maybe you're gonna need the calculator, so bring it with you. No harm in that. So let's start with the first question related to bearings. The bearing of a car from traffic lights is 60 degrees. Mr. Why this zero is there? As you know, the bearings should be always shown as three-figure number. Even if it has only two figures, we're gonna have to write zero that there. So remember, I'm not gonna go through the basics of bearings. I'm just gonna solve the idea here. So let's go and work out the bearing of the traffic light from the car. So let's draw the first one shown in the example, in the question. So it's basically a car from traffic lights is 60 degrees. So from the traffic lights, so basically I'm gonna draw X here, okay? I'm gonna write here traffic lights. Okay, so this X here means traffic lights, that's the position. I'm gonna do my straight line meaning north. I'm gonna take my protractor and try to measure 60 degrees here. Let's say it stops here at 60 degrees. I'm gonna do another line. So this another line here is for the car. So the car should be here on the other X. So this X, I chose any place I wanted. This place, for example, let's do it down here. This place, for example, I chose this place. Okay, I put my straight line of north. That's the place of traffic lights. So they showed us in the example that the traffic lights, the bearings of the traffic light of the car from the traffic light is 60. This is 60, huh? That's the bearing. That's the bearing of the car from the traffic lights. From traffic lights, I'm gonna go through traffic lights. What is the bearing of the traffic light from the car? So I have to find the bearing from the car. Basically, we're gonna go like this. Let's erase this. Let's write the car there. So I need to find this, Mr. How. Look at this. It's look like what parallel lines to you, right? So if it's this one is 60, using the rule of co-interior angles, which you're gonna go through later on in this video, they add up to 180. So subtract 60 minus 180, 120. So this part here is 120 degrees. What we're gonna do now, we're gonna subtract, because this is a full circle, we're gonna subtract 360 minus 120. So it's gonna be here, guys, 0, 0, 4, and 2, 240. So my answer is 240. Okay, my answer is 240. 240 degrees. It's in three figures, so the bearing of the traffic lights from the car is 240 degrees. That's the bearing. Very easy, right? First, I draw what's given in the question, which is 60. I choose any point, put the X in a straight line going upwards, measure using the protractor 60, stop at the end point here of 60, then make a line. The end of the line where you choose is the position of the car. Remember, from the traffic light, so the position for car is going to be here. To find the bearing of the traffic light from the car, we're going to have to go, of course, as always, in this manner, like this, clockwise, not anti-clockwise. We always measure clockwise. So we need this. We know the anti-clockwise, which is 120, because they add up to 180 together. And then we subtract 160, and there you go, you have the answer there. That's the whole idea of the first question. Repeat the video if you don't understand. Let's go to the circle theorems. I'm being fast here because we don't have much time. These are the circle theorems that you need to remember, okay? The first circle theorem is the angle between a radius and tangent is 90 degrees. What does it mean? This is a radius, guys, and that's a tangent. It's a line going through the circumference. So this is called tangent. Tangent. So we call this, guys, it's called tangent. This is, guys, radius. When they meet together, they form 90 degrees angle. Done. The first seconds. The theorem is done. The angles in the same segment from a common chord are equal. Common chord. Okay. This is called segment, guys, right? So that's a segment. Anyways. And that's chord. What I drew now is called chord. So since they are going, the origin of these two angles is from the one common chord, so they are the same. If this is 60, also this is 60. Okay, because they originate from the same chord. Let's go. The third, the angle at the circumference is half the angle at the center. So if this was 120, this is going to be 60. Okay, because the angle at the circumference, which is this one here, is half the angle at the center, meaning the angle at the center is double the angle at the circumference. Number 4, the angle in a semicircle is 90 degrees, meaning when we have, this is a full circle, right? This half is called semicircle, and the angle here in the semicircle at the circumference, exactly to be accurate, is 90 degrees. Let's look at this question. You have this diagram in front of you, and it asks you to find CAB. CAB, so this is what we need to find, right? This is what you need to find. What's the value of CAB? I will tell you for a fact the value for CAB is 90 degrees. But the question will also ask me why. Now, the answer for why, explain how, you're going to go for the circle theorems. Which one is it? The fourth one. The angle in a semicircle is 90 degrees. The angle, okay, in a semicircle is 90 degrees. If you don't write that in the exam, you will be deducted a mark. Find BDA. BDA, so we need to find this. BDA. The letter in the middle means the angle that we need to find. So, what's BDA? BDA is 19 immediately. Why, mister? Because they originate from the same chord. Look, they originate from the same chord. These two angles, they originate from the same chord. So the answer is 19. Why? Because they have common angles having common chords. What's the area of a triangle? It's half times base times height. So if you have the height is 6 and the base is 2, what's the area of a triangle? It's half times base times height, which is going to be here in this case 6 centimeter squared. What's the area of a rectangle? It's length times width. What's the area of a square? Length squared. What's the area of a circle? Pi r squared, meaning r is radius, and this question is 7 centimeter. So what I'm going to do on my calculator, I'm going to press pi times 7 squared. What's the area of a trapezium? The area of trapezium is going to be, it's known as half a plus b times height, but I would like to explain to you how we made this happen. As we know, we usually do base times height for parallelograms. It's a kind of parallelogram, but since it's trapezium having two bases, not just one base, I'm going to have to extract the average of the two bases. So it's going to be 8 plus 10 over 2 times the width, the height, which is 5. 8 plus 10 is 18 divided by 2 times 5, which is going to be 9 times the width 5, which is going to be 45 centimeter squared. That's the base, that's the area of the triangle, trapezium, which is going to be A plus B, that's called the base A, that's base B, add them up, divided by 2, the number of the bases, multiplied by the height. Okay, or this formula if you would like to use, it would give you the same answer. That's for the trapezium. Mister, is that easy? No, it's not that easy. In the exam, I'm going to connect two shapes to you. Okay, for example, I'm going to tell you the area of this triangle is 6 centimeters squared. Okay, I'm going to give you the area of the triangle is equal to the area of circle. what is the radius of the circle? I'm gonna give you everything. First, find the area of a triangle. It's 6 centimeter afterwards, right? 6 centimeters squared, right? Which is 6 equals to, what is pi r? We don't have the value of pi r squared, right? So we don't have the value of the r squared, but we do have the value of pi using the calculator. Divide both sides by pi. Divide both sides by pi. Which is going to be equal to r squared, which is going to be r squared equal to 6 over pi. Cancel the square root, both sides by square root on both sides. R equals square root of 6 over pi, which you're going to do in the calculator. This is what I'm going to bring in the exam. Similar thing, okay? Using algebra with area. Okay. Angles of parallel line. We have the first angle is called alternate angle. Alternate angle. Showing the letter Z in this way or that way. So when you have a parallel lines like this one here, this angle is going to be equal to what, guys? Look, to this angle, right? Because they're going to show something like letter Z. Sorry, this angle is going to be equal to that angle, right? So we have the letter Z. The letter Z will help us to find out the angles, the alternate angles. Also another letter Z, so this one is going to be equal to that one. So that's also a letter Z. So this and that, these two are alternate angles and they are equal. Number 2, angles and parallel lines. We have what? Corresponding angles. Corresponding angles. They show the letter F like this, So some sort of this here. These are two. Both of these are corresponding angles. Even like this, these are corresponding angles. Let's show the lines like this here, guys. So this is equal to that because they are corresponding angles, and this is equal to that because they are corresponding angles. As you know, when you add these two, it's going to be 180. When you add these two, it's going to be 180. Number 3. We have something called, which is very important, co-interior angles. Co-interior angle, which I showed in the first question in this video. Co-interior angles. The co-interior angles, it's like this. When you have two angles here in front of each other, actually they're not equal like the ones here we had before. Actually, they add up to what? Add up to 180. So if you find one of them, you're gonna subtract it from 180. The last one, but not least, we're gonna have vertically opposite angles. Vertically opposite angles. And the vertically opposite angles, they are equal. So this is equal to that, and that is equal to this. And now the last thing in our video is how do you convert metric measurements of area. So the area of something, let's say meter squared, change it to centimeter squared, or from centimeter squared to millimeter squared. First of all, we need to write the facts we know. 1 meter is equal to 100 centimeter. And 1 millimeter is equal to, 1 centimeter is equal to 10 millimeter. It's a squared. So it's basically not just when you change from 1 meter to centimeter, you're going to multiply by 100, right? So that's why it's 100 centimeter, right? But since they are both squared, it means you are going to change this to that to 100 centimeter, not just to 100 centimeter squared. Honestly, you're going to multiply by 100 2 times, then another 100. So you're going to have 200s here. So when you have 200s, at the end, you're going to multiply by 100, and then the value multiplied by 100. I'm going to give just one number here, guys. It's going to be 1, 2, 3, 4. Which is going to be 10,000. So if you want to change it from 1 meter squared to centimeter squared, you're going to multiply by 10,000. And if you want to change it from, let's say 1 centimeter squared to what? To millimeter squared, knowing the fact that when you go from centimeter to millimeter, you multiply. You're not going to multiply by 10. Actually, you're going to multiply by 10 and then by 10 again, which is basically 100. So it's going to be 100 here in this case. Okay, which is going to be 100 here, and then it's going to be 10,000. Of course, in the question, the exam, I'm going to give you a number, 5, 6, 7, whatever, okay? And that's it. That's the whole point here. It's very easy. You already know. But when you have power, of course, you're going to have 200s, which is going to be 10,000. And if you have like cube, of course, you're going to have 100 times 100 times 100, which is another number. Okay, that's really important. That's the whole revision for the topics mentioned for the exam. Bearings, we know them now, circle theorems, area of polygons, angles of parallel lines, and the standard units convergent. And that's that.